Okay, the first section of this Unit 5 on Principal Component Analysis, we're going to look at the IRIS database. You may remember the IRIS database has four features for each iris flower. The petal and width and length, and the sepal width and length. We're going to try to reduce these four features down to two features using principal component analysis. Now starting this unit, we're going to try to do a little more of a scientific process for this. So we're going to start with an hypothesis. So we'll test out if two PCI components are better than any two random features if we are training the model on this. So here's going to be kind of our experiment. We're going to look at our iris data set, and we're going to use PCA, principal component analysis, to reduce these four components or four features to two components. Then we'll also just select two of the original features of the iris data set. And then we'll train support vector machines. Remember those from last unit. Those are one of the models that can be used to classify data. So we'll use support vector machines, and we'll train it on two things. One, we'll train it on the two principal component values, and then we'll train it on the two original feature values. So here might be a visualization. So here's our original data here. We're going to break this data into two parts. The original data has all the measurements and the species there. And again, when we're doing models, we often use the X and the Y. X is the input and Y is the categories or the outputs. Since we're going to have a number of different data sets in this unit, we're going to say this is X iris and Y iris as the output here. So now we're going to take this X iris and do two things for it. One is we're just going to select two of these features and copy them down here and have a smaller set of X iris with no PCA, no principal component. So these are just examples. What if we just grab two features? How would that work? And then we're going to use PCA, and PCA is going to look at all four features, do some dimensional reduction on them, and come up with two components that should characterize most of the data in here. So our hypothesis is that this PCA data will be better data to use than this non-PCA data, even though they both just have two features or two components in them. So here's our plan. We're going to read the data in from the data set and get this iris data set. We're going to assign the four features to X iris and the species to the Y iris. So that's this process here. Then we're going to select two of the original features and assign them to this non-PCA data set. Okay. And then we're going to then we're going to train a PCA system to reduce the data, the four data elements, down to two. So we're going to train and set up this PCA system and get this new data set as a result. So now we'll look at these two new data sets visually with some graphs, this and this, and kind of get an idea. And then we'll train some support vector machines on both of these, on the non-PCA data and on the PCA data, and see the results. And then you're going to write up these results. So let's take a look at this. So step one is just to read in the data. I've got the data stored out here on the internet, and so we're just going to read in this file. I'm going to re-index it and just display the first 5 entries to remind us what it looks like. So here's again our database, and here's the species. So there's 4 features here. Now we're going to set up the input and output. And again, we generally are going to be in this class using X for the input and a Y for the output, or categories here. And so we'll set up X iris and Y iris as the input and the output variables. So we're just grabbing the 4 columns with the features and making that X iris, and then the species will be the Y iris. And again, in a lot of machine learning things, we use this X and Y. X is the input and Y in the output. We're also going to just set up the labels a little different so we can plot those down below. Now, then we're going to select just two of these features. And right now I'm just grabbing the sepal length and sepal width and making that into this non-PCA data set. So let me scroll back up to this picture. So I have this data set, we broke it up into X iris and Y iris. And then with this X iris, we're just going to take two of these. And again, you could take any two of these, but I'm just going to take two. So what I want to do is we want to see if two PCA components are better than just any two normal components. So we're just going to grab two normal components, in this case the two sepal ones, and set those up. Okay, so that's what we've got here, step 3. Now step 4 is principal component analysis. So to do principal component analysis, we have to import it from this sklearn library. We have to create a variable or a system for PCA. So we say PCA, and in it we have one main parameter, and that's the number of components. So here we're going to say we're going to use 2 components here, and so that gives us a variable, a PCA system. And now we can say use that variable. Sorry, I had renamed something. I had a typo here. Okay, so here's our variable, and now we're going to use that same variable with the same name here, and we're going to say fit transform, and this will go through all the data and fit it and create a transformation system for us. And so we provide it with our iris database here. Now we can either so in this case we're sending it all 4 components, and it's going to reduce those 4 components down to 2 components because that's what we set up. And then so we're saved. This is our new data set. So this PCA system will transform the old data set into a new data set, but this data set will only have 2 components in it. So here's the actual code. It's actually just 2 lines to do that. Now we're going to take a look at this. So again, we have these 2 data sets, this non-PCA and this PCA system. And the question is does this PCA actually let us separate the data or do better analysis of this data? So we're going to do 2 graphs first. Here's a graph of the 2 petal sepal lengths and widths against each other. So one of these is a sepal length and the other one is sepal width, and then the different color dots are the different types of iris flowers. And while this group here is pretty well separated, this group, the 2 groups here, are pretty well commingled, and it would be hard to tell one from the other if you're just using these 2 measurements here. So I'm thinking our machine learning system will have trouble differentiating these because these are all mixed together. Where here we're plotting the PCA components, so we have 2 components there, and PCA has separated the data even more than this. It has separated the data out, so it's easier to see that there are distinct flowers, and you could see maybe a machine learning system or an SV support vector machine be able to draw lines in here to separate the different flower types from each other. So that's just our visual analysis, but it really doesn't give us a really great numeric comparison. So now we're going to go on to step 6. We're going to, remember we did support vector machines last unit, so we're going to just create a support vector machine here with a linear current and c equal 1. And again, these parameters are not that important. We're just going to keep them for both of our examples here. So we're going to create a support vector machine, and then in this one we're going to fit it with the non-PCA data, and then down below we're going to do another model, similar configuration, but we're going to use the PCA data, and then we're going to score the model here. So we'll score that with the same data, and then we'll print out the results. So we'll get the result. And this will be the accuracy, what percent. So in this case, this non-PCA one recognized 82, was able to categorize 82% of the flowers correctly. And here with PCA, we're able to characterize this with 97% accuracy. And that kind of makes sense. You know, you could see here this system having a little hard time linearly differentiating these systems. But here you could see sport vector machine maybe be able to draw some straight lines in here and get, you know, most of the flowers on the right side of this stuff. Okay, so your write-up, we're going to do something a little different with the write-ups. I'm not going to ask you individual questions now. I'm going to have you just try to analyze this experiment. So in the write-up area, I want you to write 2 to 5 paragraphs describing this experiment. So just restate this, put this in your own words, demonstrate to me that you understand this, what happened here. You're going to have to look through the code in detail, run it again, try out some things and stuff. So, you know, do things. We'll want you to state the hypothesis, describe the testing process or the experiments we ran, what are the results, kind of interpret those results, and try to explain what this whole thing brings. And again, I want this in 2 to 5 paragraphs, so I expect you to provide a fair amount of detail going over this here. Okay, good luck.